Greetings and welcome, friends. Mr. Waddy here. We are talking about proofs regarding isosceles and equilateral and equiangular and therefore regular triangles. And we learned some different theorems yesterday, and we're going over the homework on page 256. You're welcome to follow along. My friends here with in real life are going to be asking questions, giving comments and feedback related to these problems, and hopefully they'll ask a question that you yourself would have had. So it says, copy and complete the statement. Copy, paste, Control-C, Control-V, am I right? And state which theorem you used. So if AB is congruent to EB, then which angles are congruent? Eliza, yeah. No? ABE, this one? Oh, there is an eventual claim that we could make if we had some more information. Substitution here, yeah? Yep, based on the base angles theorem, if I have an isosceles triangle, then the angles opposite of them are congruent to each other. Also notice that angle A, because there's only one significant angle there, I don't have to give it a three-letter full name. We don't need to be so formal. Me and angle A are on first name basis here. But angle BEA, Bay? No, I don't know. No, nah, I don't think so. Yeah, would be congruent to that. The reason is the base angles theorem. Question 6, if angle EBC is congruent to angle ECB, then what segments are congruent? BE and CE, I agree. E. All right, let's move right along. Here's a question that was not on our quest last night, but I found it intriguing, and I also thought this batch of questions was somewhat simple. I don't know, easy to apply, maybe? All right, it says find the value of x. So if this is an equilateral triangle, then I also know that it's an equiangular triangle. And if it's an equiangular triangle whose angles add up to 180 degrees, I know that each of those angles, the measure of angle F is equal to 60 degrees, and therefore by substitution 3x is equal to 60 degrees. And then by the division property of equality, divide both sides by 3. And I think I get x equals 20. No, we weren't, but I liked this problem, and I thought the other ones were pretty straightforward. Here we go. I love these ones, guys. It's like these formed together. I loved it. Oh, you can yeah, add it in the comments, Isaiah. It'd be great. So let's see. Find the values of x and y. See example 3. Oh, a little clue they gave us. All right, here's an equiangular triangle. I would then argue that these are congruent. It's also going to be equilateral. Based on that, I believe I can make the equation 8y is equal to 40. All right. Divide both sides by 8. So what sound did you guys say I make? I say wah, 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 wah. Or, I don't know. Someone during ACE was saying that I make that noise. I don't know. I need you to like give me a timestamped URL of one of my YouTube videos because I don't know of it happening. Okay, so there's the value of y. Angle of x. Oh, so devious. It'd be tempting to call this a 90-degree angle, which it is, but there's further justification before we could make that claim. I do know that, hey, 40 and 40 are the same thing. If their measures are equal, then these are congruent. By transitive property, then this is congruent to that. And by the base angles theorem, then the angles opposite of those are congruent. I know, oh, linear pairness right here. If this is 60 degrees, what would this angle be? 120. And then I'd have, let's see, let's write an equation. X plus 120 is equal to the 180. So 2x, I'll subtract 120 from both sides simultaneously. Why not? Is equal to 60. So therefore, x is equal to 30. You guys agree? And if this is 30, then that is, and that is 60, then that is, it did end up being a right angle. But you would have needed some more proof before you could have just jumped to that conclusion. All right. Ooh. So we didn't do one in the lesson yesterday, but it says construct an equilateral triangle whose sides are the given length. So I was imagining, like I drew, this is probably like 4 feet long up here, but let's just pretend that on your paper, right, this is 3 inches, all right? And what we would do, we would grab a compass, boom, all right? I would line it up. Did we not do this one? All right. Well, you guys can follow along anyway. Let's see. Can I warp this around? What I would do is set my compass to be that 3-inch radius. And watch this. Swipe it. And then watch this. Keeping the same dimensions, swipe it. Right there and there. Yeah? You guys believe this yet? Can you believe it? And let's draw those remaining sides connecting the endpoint to the intersection. Well, I'm done out of space. Oh, it rolled. Burger. Man, sorry. There we go. Now, do you guys believe this is an equilateral triangle? How do we know? Because I used radii to construct that. So this was 3 inches away. This would have been 3 inches away. What could you tell me about the angles of the interior of this? They would all be the same. They all happen to be 60 degrees because 3 angles that add up to 180 that are congruent to each other, their measures would have to be that. So I just wanted to show you that construction. There you go. Fun times. And now here we go. Mathematical connections. I can't wait to connect the maths. All right, the lengths of the sides of a triangle are the following. All right, I'm just going to draw like some arbitrary triangle here. I don't know which sides would be what. 3t, 5t minus 12, and t plus 20. Now it says find the values of t that make the triangle isosceles. Now, there's either these two are going to be equal, or these two could be equal. Or these two? Will it matter? Will it make a distinct solution? Really? Let's find out. So let's see. So I'll have 3 simultaneous equations, each of them being an OR logic between them. 3t equals t plus 20. 3t equals 5t minus 12. And t plus 20 equals 5t minus 12. Let's see. Solve these. Subtract t from both sides. 2t equals 20. Divide by 2, t equals 10. That's 1. That would result in the blue ones being congruent and therefore isosceles. Yeah, the light blue. Sorry. Thank you. Good call. The sky blue, if you will. Subtract 5t from both sides. I'd have negative 2t equals negative 12. Divide by negative 2. Don't forget to flip your equal sign, guys. You divide by a negative. Remember? You got to flip the equal sign. You got to flip it over. Okay, yeah. And so t is equal to 6. No. And subtract 5t from both sides. Negative 4 plus 20 is equal to negative 12. Subtract 20 from both sides. Negative 4 is equal to negative 3d2. Yeah. and divide both sides by, oh wow, that actually looks like an inequality. That's just sloppy. Negative 3d2, and divide by negative 4, t is equal to 8. All right, so this was the blue statement, this was the purple statement, and this was the dark blue statement. All right, so each of those possibilities of t would make a different isosceles triangle, and I think that's good enough. Thanks for watching, internet friends.